Dive into the exciting world of AI and explore foundational concepts such as AI workloads, responsible AI, machine learning, and generative AI, with a focus on their practical applications within the Azure platform. Unit 1, Describing Artificial Intelligence Workloads and Considerations. By the end of this unit, you should be able to determine features of common AI workloads, and observe guiding principles for responsible AI. Lesson 1, Identifying Features of Common AI Workloads. Introduction. Artificial intelligence is transforming industries with its ability to process complex data and automate tasks. In this unit, we'll explore AI workloads and the importance of responsible AI in ensuring ethical and fair AI practices. Topic 1, Understanding the Key Concepts of Artificial Intelligence. In this topic, we will be introduced to the key concepts of artificial intelligence, AI, and different AI workloads. These workloads are computational tasks and processes that drive intelligent decision-making in real-world scenarios. Artificial intelligence. It refers to the development of computer systems capable of performing tasks that typically require human intelligence, such as understanding natural language, recognizing patterns, and making decisions. AI encompasses various subfields, each with distinct applications and methodologies. AI enables us to build amazing software that can improve healthcare, enable people to overcome physical disadvantages, empower smart infrastructure, create incredible entertainment experiences, and even save the planet. In essence, AI is software that imitates human behaviors and capabilities. Key AI workloads include machine learning. This is often the foundation for an AI system, and is the way we teach a computer model to make predictions and draw conclusions from data. Computer vision. This is a capability within AI to interpret the world visually through cameras, video, and images. Natural language processing. This is a capability within AI for a computer to interpret written or spoken language, and respond in kind. Document intelligence. This is a capability within AI that deal with managing, processing, and using high volumes of data found in forms and documents. Knowledge mining. This is a capability within AI to extract information from large volumes of often unstructured data to create a searchable knowledge store. Generative AI. This is a capability within AI to extract information from large volumes of often unstructured data to create a searchable knowledge store. We will learn more about these AI workloads in the next units. Topic 1, Understanding the Key Concepts of Artificial Intelligence. Topic 2, Identifying Prediction/Forecasting Workloads. In this topic, we will provide an overview of machine learning and explore real-life use case scenarios that demonstrate how this technology is applied to solve practical problems. Predicting and forecasting workloads. They are key components in various industries, particularly in areas like operations, IT infrastructure, finance, and human resources. They are concerned with anticipating what will happen next based on available data. These are sample cases and scenarios where prediction and forecasting workloads are applied. Retail and e-commerce. Finance and investment. Healthcare. Supply chain. Retail and e-commerce. An online retailer wants to predict the number of units of a product sold in the next 48 hours based on traffic data. The goal is to predict the exact number of product sales or units sold in a short-term window, example 48 hours. Healthcare. A healthcare provider wants to forecast the number of patient visits over the next year, taking into account seasonal patterns, flu season, and other health trends. The goal is to forecast demand for healthcare services, example doctor appointments, surgeries, over a long-term period. Finance and investment. An investment firm wants to predict the price movement of a stock over the next few hours to guide trading decisions. The goal is to predict stock price changes or fluctuations for short-term trading strategies. Supply chain. A manufacturer wants to forecast the demand for its products over the next 12 months to ensure proper inventory management. The goal is to forecast production volume, material requirements, and workforce scheduling. Prediction and forecasting are both integral to the field of machine learning, ML, as ML techniques can be used to build models that estimate or anticipate future outcomes. Machine learning in Microsoft Azure. Microsoft Azure provides the Azure Machine Learning Service, a cloud-based platform for creating, managing, and publishing machine learning models. Azure Machine Learning Studio offers multiple authoring experiences such as Azure AutoML. This feature enables non-experts to quickly create an effective machine learning model from data. Azure ML Designer, a graphical interface enabling no-code development of machine learning solutions. Data metric visualization, analyzes and optimizes your experiments with visualization. Notebooks, allows you to write and run your own code in managed Jupyter Notebook servers that are directly integrated in the studio. We will learn more about machine learning in Unit 2. Topic 3, Identifying computer vision workloads. In this topic, we will provide an overview of computer vision, including the models and capabilities used in real-world applications. We will also touch on Seeing AI, an Azure service designed to assist individuals with visual disabilities. What are computer vision workloads? Computer vision. It is a field of AI that enables machines to interpret and understand the visual world. Using digital images, videos, and deep learning models, computer vision helps extract useful information for various applications. The workloads associated with computer vision typically revolve around processing visual data, performing complex analysis, and generating insights from images or video feeds in real time or batch processes. Computer vision models and capabilities. Most computer vision solutions are based on machine learning models that can be applied to visual input from cameras, videos, or images. The following describes common computer vision tasks. Image classification. It involves training a machine learning model to classify images based on their contents. For example, in a traffic monitoring solution you might use an image classification model to classify images based on the type of vehicle they contain, such as taxis, buses, cyclists, and so on. Object detection. Object detection machine learning models are trained to classify individual objects within an image, and identify their location with a bounding box. Object detection machine learning models are trained to classify individual objects within an image, and identify their location with a bounding box. Semantic segmentation. It is an advanced machine learning technique in which individual pixels in the image are classified according to the object to which they belong. For example, a traffic monitoring solution might overlay traffic images with mask layers to highlight different vehicles using specific colors. Image analysis. You can create solutions that combine machine learning models with advanced image analysis techniques to extract information from images, including tags that could help catalog the image or even descriptive captions that summarize the scene shown in the image. Face detection, analysis, and recognition. Face detection is a specialized form of object detection that locates human faces in an image. This can be combined with classification and facial geometry analysis techniques to recognize individuals based on their facial features. Optical character recognition, OCR. Optical character recognition is a technique used to detect and read text in images. You can use OCR to read text in photographs, for example, road signs or storefronts, or to extract information from scanned documents such as letters, invoices, or forms. Microsoft's Azure AI Vision. You can use this to develop computer vision solutions. Some of its features include image analysis, capabilities for analyzing images and video, and extracting descriptions, tags, objects, and text. Face. Capabilities that enable you to build face detection and facial recognition solutions. OCR. Capabilities for extracting printed or handwritten text from images, enabling access to a digital version of the scanned text. The Seeing AI app is a great example of the power of computer vision. Designed for the blind and low vision community, The Seeing AI app harnesses the power of AI to open up the visual world and describe nearby people, text, and objects. Topic 4. Identifying natural language processing workloads. This topic explores NLP workloads, which involve processing and analyzing vast amounts of text data to extract insights, automate tasks, and enhance user experiences. Natural language processing, NLP. It enables machines to understand, interpret, and generate human language, facilitating seamless interactions between humans and computers. Natural language processing. It is the area of AI that deals with creating software that understands written and spoken language. NLP enables you to create software that can analyze and interpret text in documents, email messages, and other sources, interpret spoken language, and synthesize speech responses, automatically translate spoken or written phrases between languages, interpret commands and determine appropriate actions. Microsoft and human interact. Players control the narrative in Starship Commander. Starship Commander is a virtual reality, VR, game from Human Interact that takes place in a science fiction world. It uses natural language processing to enable players to control the narrative and interact with in-game characters and Starship systems. NLP in Microsoft Azure. NLP in Azure leverages powerful AI models and tools to enable machines to understand, interpret, and generate human language. Azure AI Language. Azure AI Speech. Azure AI Translator. Azure AI Language. You can use Microsoft's Azure AI Language to build natural language processing solutions. Some features of Azure AI Language include understanding and analyzing text, training conversational language models that can understand spoken or text-based commands, and building intelligent applications. Azure AI Speech. It is another service that can be used to build natural language processing solutions. Azure AI Speech features include speech recognition and synthesis, real-time translations, conversation transcriptions, and more. Azure AI Translator. It uses a neural machine translation, NMT, model for translation, which analyzes the semantic context of the text and renders a more accurate and complete translation as a result. Microsoft Azure offers a comprehensive suite of tools to implement and scale NLP tasks, helping businesses automate, analyze, and enhance their interactions with text data. We will learn more about NLP in Unit 4. Topic 5. Identifying document intelligence and knowledge mining workloads. In this topic, we will cover the intersection of knowledge mining and document intelligence, focusing on how AI-driven tools can transform unstructured data into structured, actionable insights. Document intelligence workloads. Document intelligence and knowledge mining workloads are essential components of automating information extraction, organizing unstructured data, and making sense of large amounts of content within organizations. These workloads leverage AI to process documents, extract useful insights, and turn those data into actionable knowledge that can be used for decision-making and business process automation. Document intelligence. It involves using AI and machine learning to extract relevant data from documents like contracts, invoices, forms, medical records, and more. The goal is to automate the extraction of structured information from unstructured or semi-structured documents, saving time and improving accuracy in tasks that traditionally required manual processing. Sample cases or scenarios of document intelligence workloads across various industries. Invoice processing. A large retail company can use Azure AI Document Intelligence and Form Recognizer to automate the extraction of key information, example vendor name, invoice amount, due date, from invoices and integrate it into its accounts payable system, reducing manual data entry, errors, and speeding up payment approval. Legal contract review. A law firm can use document intelligence and NLP tools to automatically extract and classify key contract clauses, such as termination or penalties, allowing legal experts to focus on high-priority areas, reducing review time and improving accuracy. Record digitization. A healthcare provider can use Azure AI Document Intelligence to automatically extract key data, example patient names, diagnoses, medications, from scanned medical records, creating a searchable, centralized electronic medical records system. Customer support ticket. A customer service team can use document intelligence and NLP models to automatically categorize tickets, analyze sentiment, and identify urgent requests, allowing them to prioritize and respond more efficiently. You can use Microsoft's Azure AI Document Intelligence to build solutions that manage and accelerate data collection from scanned documents. Features of Azure AI Document Intelligence help automate document processing in applications and workflows, enhance data-driven strategies, and enrich document search capabilities. Pre-built models can be utilized to add intelligent document processing for invoices, receipts, health insurance cards, tax forms, and more. Azure AI Document Intelligence can be used to create custom models with your own labeled data sets. What are knowledge mining workloads? Knowledge mining. This refers to the process of extracting, organizing, analyzing, and utilizing valuable insights from vast amounts of unstructured data. This workload leverages advanced AI and machine learning technologies to mine, categorize, and interpret the data. Whether in healthcare, finance, legal, or marketing sectors, knowledge mining provides organizations with a significant advantage in leveraging their data to drive innovation and. Below are some sample use cases and scenarios where knowledge mining can be applied. Intellectual property search. A technology company can use knowledge mining with AI-powered search and entity linking to quickly identify related patents and competitors' innovations, helping assess novelty and avoid patent infringement. Market research and competitive intelligence. A business can use knowledge mining tools to extract and analyze data from news, social media, and market reports to uncover insights on competitor strategies, product features, and consumer sentiment, identifying market opportunities and potential threats. Fraud detection, financial transactions. A financial institution can use knowledge mining tools to analyze transaction data, identifying unusual patterns and connections that may indicate fraudulent activities. Document management and archiving. A government agency can use AI-powered search to efficiently retrieve specific historical documents from vast archives based on keywords, topics, entities, or metadata, improving accessibility and management. Azure AI Search, a Microsoft knowledge mining solution, is a private enterprise search solution that has tools for building indexes. The indexes can then be used for internal-only use, or to enable searchable content on public-facing internet assets. It can utilize the built-in AI capabilities of Azure AI services such as image processing, document intelligence, and natural language processing to extract data. The product's AI capabilities makes it possible to index previously unsearchable documents and to extract and surface insights from large amounts of data quickly. Topic 6: Identifying features of generative AI workloads. In this topic, we'll explore generative AI, a branch of artificial intelligence focused on creating new and original content, such as text, images, and music. Generative AI. It describes a category of capabilities within AI that create original content. People typically interact with Gen AI that has been built into chat applications. Gen AI applications take in natural language input, and return appropriate responses in a variety of formats including natural language, image, code, and audio. Generative AI process. Prompt/instructions. It is the initial input or instruction given to the generative AI model, which guides the content it generates. It can be a text-based query, an image, or any other type of input that provides context to the model. Generative AI model. It is the machine learning algorithm that has been trained on large datasets to understand patterns, structures, and relationships within the data. The model uses these learned patterns to create new, unseen content based on the provided prompt. Generated content. Generated content is the output created by the generative AI model after processing the prompt. It is the new data or content that the model produces, whether it's text, an image, music, or other types of content. The content is original, generated based on the model's training and the given prompt. Sample scenario: writing a title. Prompt: generate a title for an essay about the impact of poverty on education. Generative AI model: a language model processes the prompt to generate a relevant and engaging essay title based on its understanding of poverty and education. Generated output: breaking the cycle, how poverty impacts educational opportunities and outcomes. Generative AI in Microsoft Azure. Azure OpenAI Service in Microsoft Azure is the Microsoft's cloud solution for deploying, customizing, and hosting generative AI models. Azure AI Foundry is one of Microsoft's platform for designing enterprise-grade AI solutions. You can use the Azure AI Foundry portal to manage, develop, and customize generative AI models. We will learn more about generative AI in Unit 5. Lesson 2, Identifying Guiding Principles for Responsible AI. Introduction. In this unit, we will explore the 6 principles of responsible AI as outlined by Microsoft, which guide the development and deployment of AI systems in an ethical and accountable manner. These principles: fairness, reliability and safety, privacy and security, inclusiveness, transparency, and accountability ensure that AI technologies are used responsibly to benefit society while minimizing harm. Topic 1. Understanding the need for responsible AI. In this topic, we will explore the importance of responsible AI by examining the risks and challenges associated with AI, and how to address them through Microsoft's 6 principles of responsible AI. The need for responsible AI. Artificial intelligence is a powerful tool that can be used to greatly benefit the world. However, like any tool, it must be used responsibly. At Microsoft, AI software development is guided by a set of 6 principles, designed to ensure that AI applications provide amazing solutions to difficult problems without any unintended negative consequences. For more information about responsible AI, watch the following video. Responsible AI in Microsoft. Topic 2. Describing considerations for fairness in an AI solution. In this topic, we will explore the concept of fairness in AI, which focuses on ensuring that artificial intelligence systems make decisions that are unbiased, equitable, and inclusive. Fairness in AI. Fairness in AI refers to the principle that AI systems should treat all individuals and groups impartially, without discrimination, bias, or favoritism. Fairness in artificial intelligence ensures that AI models do not perpetuate existing societal inequalities or create new forms of bias. The goal is to design and implement AI solutions that produce equitable outcomes for all, regardless of race, gender, ethnicity, age, or other sensitive characteristics. Sample case/scenario. Suppose you create a machine learning model to support a loan approval application for a bank. The model should predict whether the loan should be approved or denied without bias. For more details about considerations for fairness, watch the following video. Considerations for fairness. Microsoft's implementation of fairness in AI. Azure Machine Learning includes the capability to interpret models and quantify the extent to which each feature of the data influences the model's prediction. This capability helps data scientists and developers identify and mitigate bias in the model. Another example is Microsoft's implementation of responsible AI with the Face service. Its capabilities, if misused, can subject people to stereotyping, discrimination or unfair denial of services. Topic 3. Describing considerations for reliability and safety in an AI solution. In this topic, we explore the importance of reliability and safety in AI systems, ensuring that they function consistently and securely in real-world applications. We'll discuss how frameworks and best practices can be implemented to maintain trust and avoid risks in AI-powered solutions. Reliability and safety in AI. Reliability and safety are 2 key pillars for ensuring that artificial intelligence, AI, systems operate as intended and do not cause harm or failures, especially in critical applications. These principles are essential to building AI systems that are trustworthy and dependable, particularly in high-stakes environments where failure or mistakes can lead to severe consequences, such as healthcare, transportation, or finance. Sample case/scenario. An autonomous vehicle, AV, is equipped with an AI system that allows it to navigate city streets, recognize traffic signs, and avoid obstacles like pedestrians or other vehicles. The AI system is designed to make real-time decisions to ensure safe driving under various conditions, including normal traffic, adverse weather, and low-visibility situations, example fog or heavy rain. If the AI system is not sufficiently reliable, it could make errors in decision-making that may lead to accidents. Microsoft's implementation of reliability and safety in AI. Microsoft places a strong emphasis on reliability and safety in AI, particularly through its AI products and services such as Azure AI and cognitive services. It strives to build AI solutions that are not only effective but also safe, robust, and trustworthy, ensuring that the technology performs accurately and consistently in a wide range of real-world scenarios. Azure's global infrastructure is built to deliver high availability across regions and data centers. By deploying applications across multiple availability zones and regions, Azure ensures that workloads continue to function even in the case of local outages, hardware failures, or natural disasters. Topic 4. Describing considerations for privacy and security in an AI solution. This topic covers critical aspects of privacy and security in AI systems, focusing on how sensitive data is protected and how AI models are safeguarded against potential threats. We'll discuss key strategies and best practices to ensure that AI technologies are both secure and compliant with privacy regulations. Privacy and security in AI. Privacy and security are fundamental concerns when deploying AI systems, as they directly impact user trust, data integrity, and overall system reliability. Given the sensitive nature of data used in AI, such as personal information, financial details, or healthcare records, AI systems must be built with strong privacy protection and robust security measures to safeguard against misuse and cyber threats. In an academic setting, a university implements an AI-powered learning platform that analyzes student performance and recommends personalized learning resources. Sample case/scenario. To ensure privacy and security, the platform adheres to Privacy Act compliance, anonymizing student data before analysis and encrypting it both at rest and in transit. Considerations for privacy and security. Microsoft's implementation of privacy and security. AI systems should be secured and respect privacy. The machine learning models on which AI systems are based rely on large volumes of data, which may contain personal details that must be kept private. Azure Key Vault. It is a cloud service for securely storing and managing sensitive information like API keys, passwords, certificates, and cryptographic keys. It helps ensure that sensitive data is not exposed in code or configuration files, improving overall application security. It enables users to store, retrieve, and rotate encryption keys securely, reducing the risk of exposure and ensuring compliance with encryption standards. Topic 5. Describing considerations for inclusiveness in an AI solution. In this topic, we explore the importance of inclusiveness in AI, focusing on how AI systems can be designed to be fair, accessible, and representative of diverse populations. We'll discuss key strategies for eliminating bias, ensuring accessibility, and creating AI models that cater to the needs of all users, regardless of their background or abilities. Inclusiveness in AI. Inclusiveness in AI refers to the practice of designing and developing artificial intelligence systems that are accessible, fair, and representative of diverse populations. The aim is to develop AI technologies that serve diverse groups of people, ensuring fairness and avoiding biases or inequalities. This includes considering various racial, ethnic, gender, socioeconomic, and disability backgrounds to benefit everyone equitably. Sample case/scenario. A company implements an AI-powered recruitment system to streamline the hiring process and identify the best candidates for job opportunities. To ensure inclusiveness, the system is trained on a diverse dataset that includes candidates from various racial, ethnic, gender, and socioeconomic backgrounds. Considerations for inclusiveness. Microsoft's implementation of inclusiveness in AI. Azure Cognitive Services offers a suite of AI-powered APIs that can enhance accessibility for individuals with disabilities. Features like speech recognition, text-to-speech, computer vision, and language understanding help developers build applications that are more accessible to people with diverse needs. Azure's text analytics and translator services support multiple languages, enabling businesses to build AI-powered solutions that cater to diverse linguistic communities. This helps ensure that AI models are culturally sensitive and capable of understanding and processing various languages. Topic 6. Describing considerations for transparency in an AI solution. In this topic, we explore the concept of transparency in AI, focusing on how AI models and their decision-making processes can be made clear and understandable for users and stakeholders. We'll be familiar with the tools and/or services that help ensure AI systems are explainable, auditable, and accountable, fostering trust and fairness in their deployment. Transparency in AI. Transparency in AI refers to the practice of making AI systems and their decision-making processes understandable and visible to users, developers, and other stakeholders. It involves ensuring that the workings of AI models, the data they are trained on, and the rationale behind their decisions are clear and accessible. Transparency fosters trust, accountability, and fairness, enabling users to understand how AI models work and how decisions are made, while also allowing for scrutiny and improvement. Sample case/scenario. A bank implements an AI-powered loan approval system to streamline the decision-making process for personal loans. To ensure transparency, the bank provides applicants with a clear and accessible explanation of how the system evaluates their loan applications. Considerations for transparency. Microsoft's implementation of transparency in AI. Azure Machine Learning includes tools to enhance the interpretability and explainability of machine learning models. The Interpret ML library, integrated into Azure ML, helps developers interpret black box models like deep neural networks. It provides local interpretability, explaining individual predictions in human-readable terms by showing the factors that influenced a particular decision. Topic 7. Describing considerations for accountability in an AI solution. In this topic, we will tackle about the concept of accountability in AI, focusing on how organizations and developers can ensure that AI systems operate ethically and are responsible for their decisions. Accountability in AI. Accountability in AI refers to the responsibility of developers, organizations, and stakeholders to ensure that AI systems operate in a fair, ethical, and transparent manner, and that they can be held responsible for their actions and outcomes. People should be accountable for AI systems. Designers and developers of AI-based solutions should work within a framework of governance and organizational principles that ensures the solution meets ethical and legal standards that are clearly defined. This concept emphasizes the need for clear oversight, traceability, and mechanisms to address errors, biases, or harms caused by AI systems. Sample case/scenario. The AI system of a hospital incorrectly diagnoses a patient with a serious condition, leading to unnecessary treatments, while missing the correct diagnosis of another patient. The hospital takes accountability for the AI's incorrect diagnosis and revisits its model to understand why the AI failed in these specific cases. Considerations for accountability. Microsoft's implementation of accountability in AI. Azure offers Azure Policy, which helps organizations govern their AI models and ensure they comply with legal, regulatory, and ethical standards. Policies can be set to define the boundaries within which AI systems must operate, ensuring they meet requirements such as privacy, fairness, and transparency. A healthcare provider using AI to diagnose patients can use Azure Policy to ensure that the AI model complies with medical regulations, including patient privacy laws. This helps the organization remain accountable for ensuring that the AI system doesn't violate legal or ethical boundaries.
So think about this. How often are you alive when the dawn of a new medium comes out? I knew that I had to be a part of VR because there are no rules for what VR should be. Starship Commander is a choose-your-own-adventure VR narrative that uses natural language processing, so you can actually have a real conversation with the characters.
I'm Sergeant Sarah Pearson. I've been assigned to your wing today.
When we started making Starship Commander, we had to figure out, how do we get technology that can understand what a person's saying so that we can have these new narrative experiences? We're a science fiction game. We come up with new words. No off-the-shelf software could let us put in custom words.
Who are the Echnians?
In our story, the bad guys are called the Echnians. And every time we said Echnian, it would come up with really weird words that were similar to other things that you would say. And so it would get confused all the time. So we needed to make sure that we could supply our own script. We started using Microsoft Cognitive Services to power the back end of Starship Commander.
Looks cool.
Once we plugged custom speech service into Starship Commander, I had tears in my eyes when I was playing it because it's like, oh my God, this is it. This is the experience we want.
Open the hatch.
Voice print accepted. Welcome, Commander.
You can essentially put your script in there and it knows, oh, these are the ways that people are gonna talk. And these are the phrases that they're gonna say.
Cool. What's my mission?
Must be something pretty important.
And then the second thing too was the intent detection. With Lewis, you basically give it a couple statements. After you've given it a couple statements, you crunch it and you start typing in your own statements, and it's shockingly scary how good it picks up even stuff that you didn't put in there.
Computer, use autopilot and let's be on our way.
Autopilot engaging.
I have never seen an opportunity like this, where there's a wide open playing field, no one's written the rules yet, there's going to be tons of amazing software out there, and I just can't wait to see what other people write.
We believe in the potential of AI to improve our lives in big and small ways. We need to make sure it's for the benefit of everyone.
For the first time, we're having machines move into roles that have been the roles of human beings. Might these technologies have inadvertent effects on people and society? Do they align with people's values, their ethics? We needed to think through the implications for our company.
Responsible AI is the approach that we take to developing and deploying our technology, making sure our principles are brought to life and that it empowers everyone and is inclusive and accessible for people.
Excellent!
The job of the Office of Responsible AI is to put our principles into practice by operationalizing ethics across the company.
We have to think through what it means to detect bias, make our systems more fair, to detect errors and blind spots in our technologies, and on thinking through the kinds of advice we give to other organizations and to our leaders where technology can impose on privacy and human rights. Responsibility is at the core. We're learning every day about this new role of responsible computing.
We need to translate academic thought to language that our engineers and salespeople are familiar with. Our customers are grappling with many of the same issues. It's incumbent on us to share what we learn.
It's about trying to do better every day, working with our customers and outside agencies to develop processes and deliver responsible computing technologies to the world.
So right now, we do live in a society that is unfair and biased in many different ways. And I think the whole point of focusing on fairness in AI systems is to make sure that the systems that we develop and we deploy reduce unfairness in our society rather than keep things at the same level or even make it worse. And for me, that's really the goal. We've seen a lot of news stories over the past couple of years about AI systems that are used to allocate or withhold opportunities, resources, or information in domains like criminal justice, employment and hiring, finance, credit. AI systems can reinforce existing societal stereotypes. Another example would be cultural denigration. We also have over and under representation. There isn't a single definition that we can easily quantify and just integrate into our systems. Fairness relates to not just the system, the technical component, but it relates to the societal context in which the system is deployed. And that means that fairness, in the context of AI systems, is a fundamentally socio-technical challenge. This means that we've got to have a greater diversity of people developing and deploying AI systems. And what we see is that the assumptions and decisions made by teams at every stage of the AI development and deployment lifecycle can introduce biases. And that's why this is such an important topic. This isn't something that we can just sort of delegate to one or two people and call it quits and move on. No, this is something that everybody has to be thinking about really actively.
Reliability and safety is a concern for every AI system we develop. We need to make sure that the systems we are developing are consistent with the design ideas we have and working in a way that it is consistent with our values and principles. And this requires that our systems, our models, are not creating harm in the world. And if there are situations where they may be making mistakes, we actually push products out there with quantified and well-understood risks and harms in a way that we actually share that with our users. This is kind of the guiding principle we have with respect to reliability and safety, and it is really a concept that applies to every AI product we have in the company. When we think about safety, the first examples that come to mind are self-driving cars. But it's not even limited to those physical systems, physical agents. We actually worry about harm to human lives when a machine learning model is making predictions about people's health in hospitals, when they are making predictions about diagnosis. Wrong assistance can lead to harms for people. So those are the cases that we really worry about because the threat is to human lives. But this doesn't mean that this issue is only for those physical systems. Reliability is a big concern, and small mistakes may pile up when a system gets used many times across a large group of people. And that's why it is a concern for everything that we build.
Privacy is a fundamental right, and Microsoft has a long-standing commitment to privacy and security in the systems and products that we build. With AI and machine learning, we add new complexity to those systems and an increased reliance on using data to develop those systems, to train the systems. That increasing reliability on data adds new requirements for keeping the system secure. For example, we're using more data. We need to ensure the protection of that data, that it's not leaked or disclosed. One of the ways we approach that is to not remove the data from a customer's device, to run the models locally on the device, eliminating that potential vulnerability. When we consider the security aspects of these AI systems, you have to think through where and how the data is coming from. If it's user-submitted data or a public data source that's being used in the prediction, how do you prevent that from being corrupted? Having things like anomaly detection or other systems for detecting changes in the data that might indicate that there's an adversary trying to influence the results of the system.
If we think about what we're really trying to achieve, we want to make sure that we as Microsoft empower and engage the communities around the world, making sure that no one is left out, making sure that we are intentionally inclusive and intentionally diverse with the approaches that we take towards AI. We want to make sure that that full spectrum of communities are covered. And if we truly think about how we can design for the 3%, we can then solve for the 97% at the same time. We want to make sure that experiences like seeing AI, speech-to-text translation out of PowerPoint, and other technological examples that we have that we're building upon, including the Microsoft accessibility standards, represent just an example of the extensive toolkits that we have here to ensure everyone truly designs for an inclusive AI future. As a woman of trans and non-binary experience, and also being Latinx as part of the underrepresented minority community, ensuring that these future experiences are truly representative of the underserved minority communities, we need to make sure that they're involved both in the earliest concepts and feature design and planning, but making sure that they're part of our testing, that we are also building with, side by side, individuals to make sure that we are not taking an ableist perspective for the population we intend to serve.
Transparency and intelligibility can help us achieve a really diverse range of goals. So things from mitigating unfairness in machine learning systems, to helping developers debug their AI systems, to gaining more trust from our users. There are two sides to transparency. In part, transparency means that the people who create AI systems should be open about how and why they're using AI, and also open about the limitations of their systems. Transparency also means that people should be able to understand the behavior of AI systems. This is what you often hear referred to as interpretability or intelligibility. The choice of a training data set determines the behavior of a machine learning model. So how can we bring more transparency to our data? We propose that every data set be accompanied by a data sheet that documents its motivation, its creation, its maintenance, its intended uses, and so on. Data sheets for data sets help data creators understand and uncover potential biases in their data that they may have missed or unintentional assumptions that they were making. And they help dataset consumers determine if a dataset is right for their needs. We've put together an initial set of questions that we think cover the important information that a data sheet should include. And we've been piloting these questions with teams across Microsoft. Together with the Partnership on AI, we plan to extend this idea to bring transparency to other parts of the machine learning lifecycle, like trained models and APIs.
Despite all the complexity with these new models and with new technology that can be somewhat unpredictable and somewhat hard to interpret, we are still accountable for how our technology impacts the world. Second, I think about accountability as the structure that we put in place so that we make sure that we consistently are enacting our principles and that we're taking them into account in everything that we do. Also, part of our accountability is to help our customers and partners be accountable. We have a set of principles that guide how we develop and how we sell and how we advocate for regulation on facial recognition, because we feel like all three of those pieces are really critical to be accountable. We think it has a lot of great uses, and we also think there are a lot of uses that could interfere with people's civil liberties or push society in a direction that we're really not interested in supporting.
So in moving from our facial recognition principles to practices and processes that we can follow across the company, what we've had to do is to take a high-level principle, such as our commitment to fairness, and think about how do we have our development teams view every stage of the development lifecycle with those principles. So today we have a set of guidelines that they can follow and think about these sorts of considerations at every step of the life cycle. And that's really a first in this company, and I think in many other places outside this company as well.